Hello everyone. In this video we're going to learn about exponents and some basic laws of exponents. First of all, what is exponent? So exponent is a mathematical notation of writing a number multiplied by itself several times. Now what does it mean? Let's say you have a number 5 which is being multiplied by itself several times. Let's consider 4 times, right? Now, this is the product of 5 which is being multiplied by itself 4 times, right? Now, mathematics give me a facility to write down this expanded form into a short form. That short form is called exponent, right? Now, that mathematical notation is whatever the number is that will become the base, right? And then we'll put bracket and then we'll write down a number on the top which becomes the superscript, right? Or it is called as power. Now how many times this number is being multiplied? 4 times, right? So that number 4 goes in the power. So your mathematical notation becomes 5 raised to power 4, right? So this is the exponential form of writing this product. Another example, let's say -3 is multiplied 5 times. So -3 times -3 times -3 times -3. As you can see here, it's difficult to write down the product of a number by itself several times, right? So we're gonna use the exponential form. Exponential form is we'll write down the number which is being multiplied, that is -3, and how many times it is being multiplied? 5 times. So that 5 goes on the top, right? So your exponential form becomes -3 raised to power 5, right? In this notation, if we consider the standard form where the number being multiplied by itself is denoted by A and how many times it is being multiplied, that is denoted by N, then in standard form the exponential form is A raised to power N, where A is called the base and N is called the exponent, right? Which means A is being multiplied by itself N times. Now we have how to calculate the value of exponents, right? Now my first case is if the base is positive. Positive means we have considered 3 times 3 times 3. So this base is positive. No sign means it is positive, right? How to calculate the values of exponents when the base is positive? It's very simple. Let's say you have 3 times 3 times 3. This will become, that means you are multiplying 3 times. This becomes 27, right? Now using exponents, 3 times 3 times 3 is 3 cube, right? If you are using calculator, then you will input 3 first. The base goes in the calculator first, and then you will use this feature y raised to power x. I'll show you this feature. So this is y raised to power x, right? Once you input the base, you will enter this feature and then enter the value of exponent, which is 3 in this case. So your screen will display 27. That is how we calculate exponents using calculator. I'm going to show you another example. 4 cube. Now, if we calculate it manually, it is 4 times 4 times 4, right? Which is 4 times 4 is 16, 16 times 4 is 64, right? That is my manual method. If you use calculator, then you'll input 4 first, which is the base, and then you input y raised to power x feature, and then input 3, that is your power, the exponent, and the screen will display 64. Okay. Next, if the base is negative, it's nothing different if you are using calculator. So you'll input your negative base. Let's say the base is -5. How would you input this in your calculator? So you'll input 5 and then use this feature in your calculator. Your screen will display -5, right? And then use this feature y raised to power x. I'm gonna highlight the features, and then you input y raised to power x, right? Now it's time to input the power, the exponent, right? If the exponent is 3, input 3 here, and then your screen will display -125, right? So this is how you calculate using calculator. If you're calculating it manually, let's consider this. Okay, so here we have two cases. If the exponent is even number, the answer is positive. What does it mean? Let's consider this example. We have -1, exponent is 2, which is even number, right? If we expand this exponential form, what do we get? -1 times -1. And we have learned in integers, negative times negative is positive, right? So that means our answer will become positive. Second example, -5 cube. When you expand the product, you write down -5 times -5 times -5, right? So that means negative is being multiplied 3 times. So negative times negative times negative. What is it? This is again negative, right? Because negative is multiplied 3 times. So answer is negative. And then you multiply 5 and 5 and 5. So you get -125, right? Let's say the power is positive. If we consider -5 raised to power 4, what will happen? Power 4 means we are multiplying negative 4 times, right? Negative times negative times negative times negative. Now negative times negative is positive. Negative times negative is positive again, and then positive times positive is positive, right? When you multiply negative even number of times, you get result positive. Or you can say negative is existing in pairs. So 1 pair, 2 pair. There's no negative left odd, right? There's no negative left out. Sorry, no negative left out. So pair, negative exists in pair, right? So that means the result will be positive. So you get 5 raised to power 4, which is 125 times 5. Okay. Okay, next we have, if the base is not a whole number, it's either fraction or a decimal. How to calculate the exponent then? So here I have first example. which is 4 upon 3 whole raised to power 2, right? If you have a fraction with some exponent, it means this fraction is being multiplied 2 times, right? And how do you multiply the fractions? So you multiply top by top and bottom by bottom, right? So you get 4 times 4 is 16 and 3 times 3 is 9, right? So you get 16 upon 9. Again, let's say next comes laws of exponents. There are many laws of exponents, but we'll go one by one. Let's consider the very first law. How to multiply the powers with the same base. So this is the first law where it says if we have the same base, we can add the powers. Let's consider one example here. We have 3 square times 3 cube, right? Now the bases are same. 3 and 3. Bases are same. Law says if you have the same bases, you can add the powers. So that means 2 and 3 will be added. So you get 3 raised to power 2 plus 3, and that is 3 raised to power 5, right? Another example here. So again, 2 is the common base, right? So you'll add the powers. So 3 plus 2 plus 4, and that becomes 2 raised to power 9. That's your answer. It is true for negative base as well. Let's say you have negative 3 square times negative 3 cube, right? What will be the result now? Now negative 3, common base, right? So let's write it down just once and then we'll add the powers because there is product in between, right? So 2 and 3 will be added, 2 plus 3, and that becomes negative 3 raised to power 5, right? If you want to solve it further, let's solve a negative exponent 5. Now negative has odd exponent, so your final result will be negative, and then you get 3 raised to power 5. You can note here I didn't use the brackets anymore because my negative sign is out of the bracket. It's being solved now, right? So I have only 3 raised to power 5. You can calculate 3 raised to power 5. So you'll input 3 in your calculator and then use feature y raised to power x and then input 5. You will get 243. Right? That's your final answer. Or it depends what do you need. Maybe sometimes you just need answer in exponent form or you need the whole solution. You will get negative here, negative 243. So that is a whole number with negative sign, and this is the exponential form of the answer, right? Okay. Next comes division of fractions. Okay, division with the same base. Now the second law says if the bases are same and you have division sign in between, then subtract the powers, right? Subtract the exponents. Let us consider one example here. 3 raised to power 5 is divided by 3 cube. Now the first thing you need to note is the bases are same, right? If bases are not same, let's say you have 3 raised to power 5 divided by 4 some exponent, then this rule is not applicable. You'll have to use another method to calculate the value, right? So this rule is not applicable for this sum, right? There is solution to this question, but you'll use different technique for this. This law is applicable only if you have the same basis, right? We'll talk about the solution of this question later on. Let's talk about the law of exponents now. So 3 raised to power 5 divided by 3 cube. Because the bases are same, you're going to subtract the exponents, right? So 3 raised to power 5 minus 3, which becomes 3 square, right? That could be one of the answer. If you are supposed to solve the whole answer, then 3 square will become 9. That might be one of your answer, right? It all depends in what form you need the result. Another example I have is where we have three bases, 2, 2 and 2. Base is common, so we're going to just subtract the powers, right? So 7 minus 2 minus 3, and that becomes 2 square, and you finally get 2 raised to power 4, right? Let's do the combination of these. I'm going to do the combination of these where I'll use multiplication as well as division. So let's consider one example. 5 cube times 5 square divided by 5 raised to power 2. Oh, 2. Right? Okay. Again, it is a combination of multiplication and division, right? The first thing you will note is the bases are same. So let's do it. 5. Okay, I'm going to write down the exponents of the numerator first because they are being multiplied. My law says for multiplication the exponents should be added. So I do 3 plus 2. Right? And at the same time, you can consider the denominator as well, which is with the same base, and exponent is 2. And my law says in division, subtract the exponent. So subtract 2. Right? So this is 5 raised to power. 3 plus 2 is 5. 5 minus 2 is 3. So that this is 5 cube, which becomes 125. Right? Next law is power of a power. It says if you have a base with some power with another power, so you have double power, right? Power of a power. Then the law is keep the base as it is and multiply the powers. So inner power is being multiplied with outer power. So simply multiply the powers, keep the base same, right? Let us consider example here. So you have 3 square whole cube, right? So you have double power here. 2 is an exponent and 3 is another exponent. So by law, you're going to multiply 2 and 3, keeping the base same. So 3 stays as it is. 2 times 3 becomes 6. Right? So that's your answer, 3 raised to power 6. Let us consider another example. Let's say you have negative 5 raised to power 2 and then whole raised to power 5. Now again, you'll keep the base and double powers are being multiplied, right? So 2 times 5 and that becomes negative 5 raised to power 10, right? Okay, next law, number 4. So it says if you have power of product or quotient, then it is equal to the exponent of individual bases, right? So you have different base here, a times b with same exponent. What does it mean? Now this exponent is being expanded on each base. So this becomes a raised to power m times b raised to power m. And this is true for in reverse manner as well. So if you see somewhere a raised to power m times b raised to power m, this becomes a times b raised to power m, right? So it can go either way. It can go either way. Let's say you have one example, 2 times 4 square, right? I'm going to consider this example. Now what does it mean? It becomes 2 square. That exponent goes with this 2 as well as with this 2 times 4 square, right? Okay. Now another way of using this law is, if you see somewhere negative 5 raised to power 3 and then times 6 raised to power 3. So instead of calculating each single exponent, what you can do is you can combine the bases. So negative 5 times 6, right? I can combine the bases only because I have the same powers. So it becomes negative 5 times 6 and the exponent becomes the common exponent. Now it's easy to calculate. You are using just one step to calculate the exponent, right? So negative 5 times 6 is negative 30 and then exponent is 3, right? Okay. Next law, very important and simple law of exponent. It says any number raised to power 0 should be replaced by 1. Any number raised to power 0 is 1, right? We have considered one example here. Let's say you have 2 cube upon 2 cube. Now by law of exponents of division, because the bases are same, powers must be subtracted, right? So keeping one base 2 and then subtracting the powers, we get 2 raised to power 0. And the law says whenever you have any number raised to power 0, it should be equal to 1. So this becomes 1. And this is the explanation here why it becomes 1. So if you expand 2 cube, what do you get? 2 times 2 times 2 in the numerator, and in the denominator again 2 times 2 times 2, right? If you solve this fraction, this 2 cancels with this 2, second 2 cancels with second 2, and this 2 cancels with this 2, and you are left with 1, right? So this is the simple explanation of this law. Any number raised to power 0 is always 1, right? Just remember this law. Anything raised to power 0 is 1. Okay. Okay, next law is negative exponents. This law says if you have negative power, to calculate it, just flip the base. Just flip the base and the power will become positive, right? Let's say you have a raised to power negative m. To make this exponent positive, what you can do is just flip the base. Or you can say find the reciprocal of a. What is the reciprocal of a? That is 1 upon a, right? And then power m. Now the power is positive. It's not negative anymore, right? That's the rule. So if you want to make negative exponent positive, just flip the base, right? Okay, let's consider one example. You have 5 raised to power negative 2, right? Now it's hard to calculate negative 2. You can use calculator, right? It's easy with calculator, but if you are doing it manually, the law says you can flip the fraction. So this 5 becomes 1 upon 5, right? Once you flip the fraction, your exponent becomes positive. So this becomes 2, and the answer to this is 1 upon 25. Okay. Here we have considered one example, 3 square upon 3 raised to power 4, right? Now the law says if you have the same basis, exponents should be subtracted. So this becomes 3 and then 2 negative 4, which is negative 2, right? If you come across negative exponents, one method is you can use calculator, right? I'll show you the steps with calculator later. And second method is you can solve manually using the law. And law says flip the fraction, flip the base, right? So this 3 is this 3 becomes 1 upon 3, right? And then with positive exponent, that is 2, and the result is 1 upon 9. When you calculate its value, this comes out to be 0.11111. I already calculated this, so I know the value here. Okay, using calculator. So you'll start from this step. So you'll enter 3, that is your base, and then enter 2. This should not be here. So enter y raised to power x. You'll use this feature y raised to power x. Okay, right? And then enter 2. But your exponent is negative here, right? To make it negative, you will enter this feature, and then your screen will show negative 2, and then you press enter. Your screen will display the result in decimals, that is 0.1111, right? So that is calculator method. Okay, so this is the time to check your understanding. You can pause the video for 3 to 4 minutes and then come back to the video. I'll show you the answers. Please pause the video for 3 to 4 minutes. Welcome back. This is the answer to exit key. If you got all the correct answers, congratulations. But if you didn't get the answers, please watch the video again. Thank you, everyone.